All right, welcome. This is a video for M2T1 and M2T2 for CSC134. You could skip this or use the old video, but hopefully it will be helpful. All right, let's get started. First of all, you're going to notice the dates on these have been pushed out a little bit. So I will often try to talk about material in person in class and in videos online well before it's actually due. So I encourage you kind of to be a little bit ahead of the curve. It just gives you some room to work with if you get busy a week in some other class. If you can drop back a bit and not yet be behind in our class. So this first assignment, we're going to make a simple receipt, and we're going to look at a couple ways to do that. Now, one of the things you'd find if you kind of go digging into some of these other readings, let's go back. I found some kind of neat stuff about formation. I went way too far, sorry. All right. Fantastic. So there's a couple of things here where I notice that in some of these examples, now again, this will be in your Zybooks, but it's probably not in the section we've covered. So we're going to do some fancy stuff here just to try it out. Now, if you turn in your program and don't add the extra, what I call post-processing to make it look nice and neat, which is in this reading, then that's okay. I can live with that, but I thought while I'm here, I would show you. Now, we're not going to use this yet, so I want to just keep this slide up for when I come back to it. But the idea is we can format our data in a certain way that's going to be, sort of pleasing to the eye. Even though we're writing code for a computer, we need to be thinking about the people involved. If you're writing a program and it's not just for goofs or for fun or for an assignment, then presumably a human being actually needs this program. And so you should make it pleasant for them to use it, or at least not unpleasant. And that means there's a couple of things you have to think about, like what does my output look like? If I'm asking a question, did I ask the question in a way that makes sense to them? Is the output readable? So we're going to go with our usual boilerplate. I sort of want you to sort of type this stuff without thinking about it, using namespace standard. All right, and so this problem is going to be a receipt generator. So let's put a little message here. Thank you for dining. You put whatever here. It's just the idea is that we know it's a receipt. Okay. So let's see. A little pseudocode, determine the price of the meal. We've already seen in this assignment it's hard-coded, so we won't have to even use CN for this assignment. In the next one we will. Calculate the tax amount in dollars and total in dollars. Okay, I'm going to put in dollars. Why would I put in dollars? Because, well, we're using either a double or an int, and they don't have a unit. So I would want to specify what my units are. So I'll say double meal price, double total price, right? And so now I'm going to need a couple other values, right? So here's the thing. If I just say tax, right, so I got to say double tax. What does that mean? Because there's two taxes. There's a tax rate, which the assignment says is 8%, right? And then there's the tax amount, which is in dollars. Okay, let's put that right in dollars. Okay. Well, in this assignment, we know it's $5.99 for the meal, so that's fine. In another assignment later, we might use a CN to get that message. Okay, so that's done. So we know the price of the meal. And now I want to determine these amounts. Maybe before I do that, I'll just sort of make sure my program is working properly. So I might say cout meal cost Indo. Okay. Maybe something a little fancy here, so I'm going to show you what I mean here. What's that? That's a tab character. Meal price. Let's run that. This is what I mean by formatting. So my thought would be, well, if you were to go look at a receipt, like just Google image search a receipt, right? You're going to have text on the left-hand side items on the right-hand side, like it's a paper tape that was used for accounting, that type of thing, or bookkeeping. It's just printing out these values. So I might say cout tax, right? And you know, while I'm at it, let's put a little dollar sign. That might look nice. I feel like I have kind of a Bob Ross happy little cloud thing going on. That's fine. Tax amount. Okay. And cout total. And you know, sometimes it occurs to me, I'm not really sure how all this works when you're watching a video and then have to type. If you've got two screens, it definitely helps. Or make it a small window. Sometimes I'll put videos on the TV while I've got my laptop. It may just depend on how you want to do that. All right, so I don't have total price. All right, so what are the types of mistakes that are easy to make? Well, you might pick the wrong variable name or forget the names. Right. How would I determine the tax amount in dollars? I'd say tax amount and set it to the value. So it would be total price times tax rate. Right? Makes sense. $5.99 times 0.08 is going to give you whatever the tax is on $6 of purchase. And then I would say total price equals meal price plus tax amount. You know, if I'd called it tax price, that probably would have been flowed a little better, but that's all right. So here I've got, you know, no input. I'm hard coding these values. So you could imagine that later I'd want to maybe add something to say, hey, how much was your meal? And then it will calculate it. I've got my processing or calculation where I figure out these values. 8% of $5.99 is going to give me, you know, some amount, and that will add to total price. And then I print it in kind of a fancy way. So not super fancy, but just kind of interesting. Okay, moment of truth. Good, not a number. That looks like that worked out really well, right? So what you can see here is my program is functioning. I didn't get any errors, but it is obviously wrong. So let's think about how we might figure out how it's wrong. So I'd say, well, total price is undefined. So this was a big old mistake, right? The tax amount is not the total price because I don't know the total price yet. It's the meal price. Okay. So the tax amount is, you know, 8% of the meal price, which is $5.99. So like 40 some cents. And then total price will be add the tax, and then you get a receipt that looks like you would expect. So that's good. So by running the program before I turned it in, I find, whoops, I made a big old mistake. Interesting that it showed nan, not a number. There's times where you might see, for example, just 0 or just some random value for an undefined variable. Okay, cool. So this is working, but it's not very pretty, right? And the reason is because when I tell somebody they owe me $6.46.92, they're going to look at me funny. In the same way, if I tell them they owe me $6.04, they're like, well, is that 40 cents or 4 cents? So we're going to keep the decimal points. And while it's not required, if you go into this chapter 3 reading, let's go dig it up and see, under this 3.7 formatting output in the Gaddis chapter 3 slides, I have to add the iomanip header file. And I could set a line a certain width, which is cool. And that's nice. But what I want to really do here is this fixed and set precision. So I'm going to show you what it looks like. Okay, so I'm going to include. Now there's a lot of these includes out there that are part of they're built into the language, but it doesn't use them by default. Just like if your program doesn't have 3D graphics, then why would you include all the code to draw 3D graphics? In the same way, if you don't need this library, you don't include it, and if you do need it, you do include it. All right, so I'm going to do set formatting for output. And it's going to be this, cout set precision to fixed. Cool. All right. Now, you know, you could look this up and memorize all the details and learn how set precision and fixed work. But the TLDR version is this line will ensure that all subsequent values printed use exactly 2 decimal points, right? If I had set them to 3, which I wouldn't do for money, but just to show you how it works, then it would do this. So it turns 599 into 5.990, right? So it's just going to always set these values. So it's rounding off Let's actually check that. So it's 6.469. So it should be 6.47, right? Let's see what happens. But it's looking more and more like a receipt now, at least. That's good. There we go. Looks good. So it actually does round it up properly. We don't want to get into what happens with fractional pennies. Some banking systems work with fractional currency, some don't. But it could get pretty confusing. So by always printing out exactly these values, it's going to look nice. Now, just for one other thing, what if I change the price to, let's say $5 instead of $5.99? Because we use the fixed and set precision, it's going to look correct, right? If I did not use that line, you notice how it looks, and notice that it's just not particularly readable, or it's a little hard to read. You have to kind of stare at it to go, that is a price, right? 0.4. I mean, like that. Some people might go, well, is that 4 cents or 40 cents? And maybe that's a dumb question, but when you're writing the code, it's up to you to make sure that everything is readable and presentable. So we want to think about those things. So let's do a quick scan to see all the code. It pretty much fits on one page. We do run into a problem of pretty soon our programs don't fit on one page unless I use a very small font. But we're good. So again, let's remember how would I finish this assignment. Well, first, I would click here, I would download a zip, and I would rename the REPL if I didn't rename it already. Of course, I could have just renamed it up here and then downloaded it. So I recommend you give this a good name. Once it's downloaded, you have a zip. The next thing you want to do is take a screenshot of this screen and upload the zip and the screenshot. So that's it for now, and I'll move on to the next video.